Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich season on German deck coming about to the Zurich International Airport runway 1449 Ilsloc localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wing 787-900 model Boeing 787. I'm gonna show you the cockpit instruments that displays the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the radio altitude above the ground level, the barometric altitude above the sea level, and the altitude selected from the autopilot and flight director system panel. The barometric pressure, the magnetic heading, magnetic north pole, and north pole magnetic variation depending where we are in the world. We have the primary flight display with the altitude indicator and the artificial horizon and the pitch level in degrees and the bank angle in degrees. So you can see here these instruments, the primary flight display, the navigation display, the AUGUSR, the education and crew alert system display, the autopilot and flight director system panel. So I will be showing you all these systems. So also you're gonna see here also we have the flight mode demonstrated with the autopilot and the auto throttle later and vertical navigation modes. We have the islands localizer, crossbars, and for with the horizontal localizer and the vertical glide slope. For guidance into the runway heading and landing. So we have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We also have the angle of attack of the aircraft as it flies, and the ILS localizer tuned freighting information. So we have also the navigation display that displays the terrain map with the weather, also reflections, the other aircraft, the fire aircraft. You can see other aircraft with the diamond shape, the distance they are located, the altitude difference, the direction, and the airspeed that they have. So this generates the TICA system traffic collision alert system warnings. So you can see also we also have the airports, the waypoints, the nav aids, the navigation aids, the data stored from the flight management computer. So you will see the airports with the allocator, the position, actual position. You can see our own airport runway we're gonna use for takeoff. We have selected already using the flight management computer. So you will gonna see also that. I'm gonna show you also how we're gonna create a flight plan. I'm gonna show you how we're gonna calculate the takeoff speed. We're gonna input the takeoff gross weight of the aircraft. That includes the empty weight plus the passenger plus the cargo plus the trip fuel plus the reserve fuel plus the taxi fuel. So this is gonna make the calculations using the flight management computer. Using the control display unit of the takeoff speed, we're gonna calculate the center of gravity and the mean aerodynamic chord position of the aircraft, and also the horizontal tail trim stabilizer position for takeoff and then for flying from climb, cruise, descent, approach, and landing. We're gonna have also the horizontal tail trim calculation, and this is gonna be done using the auto trim, or we can use a manual trim using the horizontal trim stabilizer and the control wheel of the yoke of the Boeing 787. We have also in the navigation display, we have the display of the waypoints and the flight plan we have created. So we're gonna use the runway we're gonna use for takeoff, the runway length, the runway conditions, which is ice, dry, or wet, the slope of the runway, the outside atmosphere pressure and density, and the temperature of the air, and the wind direction and speed. And we're gonna have the takeoff speeds using also the flaps, as I told you, in the mean aerodynamic chord position and the center of gravity. The mean aerodynamic chord of the forward wings, the chord of the forward wings, what is the position where the maximum aerodynamic lift occurs in the forward wings. Also the stall begins in the forward wing. and the horizontal trim stabilizer. We're gonna have the takeoff speeds V1, V-rotate V2 using the flight management computer. Also, we're gonna input the data for flying the aircraft. We're gonna create a route or a flight plan or a flight path. You're gonna see that with takeoff climb. So we're gonna have the seats, the start arrangement, departures after the initial climb. We have the intermediate waypoints and fixes that includes all horizontal and lateral navigation waypoints and fixes we have to cross through. You will see in the flight plan line in the navigation display. We're gonna have to follow during the initial climb of the aircraft. Then the cruise, then the descent and approach to the destination airport and runway. We're gonna have the stars, the starter terminal arrival waypoints and fixes, and the Lszh localizer of the destination airport runway. We're gonna have the heading selected for the destination runway we're gonna use for landing, and we're gonna have also the Lszh localizer of the destination airport tuned automatically using the flight management computer or manually using the radio management panel. So you're gonna see the Lszh localizer frequency, and we have to use the runway direction heading, magnetic heading, and also this is gonna give us the horizontal localizer and the vertical glide slope, the needles, and the Lszh localizer crossbar for landing, for guidance landing to the runway. So you're gonna see also this thing. We're gonna have also I'm gonna show you the autopilot. So this is gonna give us the complete flight plan. It's gonna be used also from the autopilot and flight director system panel, just in case we need the LNAV and the VNAV, the lateral navigation and vertical navigation of the aircraft using the autopilot and flight director system, as you can see here. So I will show you the autopilot and flight director system panel, the autopilot engage and disengage switch, the auto throttle left and auto throttle right. It's all the systems are the same with the Boeing 777-300ER. So you will see the autopilot engage and disengage switch, the auto throttle left and auto throttle right, the flight director engage and disengage, the airspeed select no. We're gonna select an airspeed nautical miles, neutral, max speed, and this will command the engines of the aircraft. FADECs. The FADECs are the full authorities electronic control computers, one installed per engine. Dual channel redundancy. If one channel fails, the other takes over. So the FADECs control, monitor, and display all the engine data and functions using the AUGUSR, the engine indication controller system display. Like the N1. The N1 is the low-speed starter and stop, the pressure, compressor, and turbine of the turbofan, which is engine, the exhaust gas temperature per engine. The N2, which is the high-speed starter and stop, the high-pressure compressor and turbine of the turbofan, which is engine. The fuel flow per engine per hour, thousands of kilograms or thousands of pounds. The oil temperature, oil pressure, oil quantity, and the vibration of the N2 stage of the engine. Also the pressurizer, the outflow of the pressurizer from the 5th and the 9th stage of the fan blades of the starters, and also the other things like the engine start, engine failure, fuel mixture, and other sensors. So we're gonna have the FADECs control the engines. We have, I think it's the GNX engines, we have Honeywell engines, and the 787Z engines. So we're gonna have, you're gonna see here, when we move around. So this is the autopilot flight director system panel here. You can see we have the same functions like the 787. We have also the head-up display over here. So you will see a lot of stuff happening. So we will decrease the range here. You will see the flight plan. You can see the terrain map here. You can see the autopilot and flight director system panel. Maybe we can use also this side. You will see the flight plan here. We have to activate that. Execute, and here is activated. So we have You can see also the flight controls. We can move around. Use the flight controls for flying the aircraft. So I'm gonna show you also that. So we have the autopilot engage and disengage switch here at the auto throttle. This is the airspeed guidance of the aircraft, the heading guidance, the vertical rate of climb descent of the aircraft, and the altitude select, the same like the Boeing 777. Also other things you see is the same like the 777, the primary flight display, the engine indications and flight management computer, the thrust levers and they look the same, and also the overhead panel and the function pretty much the same. Also the flight controls the same. So most of the cockpit. So we have also the autopilot, as I told you, engage and disengage switch. The airspeed select knob, we can select an airspeed to nautical miles knots or max speed, and this will command the engines, as I told you, the farecs. They will move the thrust levers forward, or you can move the thrust levers on your own without the auto throttle. You can disconnect the auto throttle and take the manual thrust over here, moving the thrust levers forward and aft. As you can see, so you can see here we have the N1, which is the low speed starter and the low pressure compressor and turbine of the turbofan turbojet engine, the exhaust gas temperature per engine, the N2, the fuel flow, the oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So you will see a couple more things. As I told you, the airspeed select knob, we have the fixed thrust mode and the variable thrust mode. When we climb or descend, we have fixed thrust of the engine. FAREX commands a fixed thrust, and the airspeed is being adjusted by varying how fast the aircraft will climb or descend. The horizontal tail trim elevator order, or as we know, when we are cruising horizontal level or we approaching landing, we have the variable thrust mode, in which the airspeed has been adjusted by varying the thrust commanded and produced by the engines. We have also the bank angle limit hold switch for the cruise level, the heading select knob, the heading hold switch, the vertical rate of climb of the aircraft depends 100 and 100 feet per minute, the altitude select knob, the altitude hold switch, and also the VOR localizer for the non-ILS localizer approach, and the approach switch for the auto run function of the Boeing 787-900. So you can see here an overview of the 787, the outside. So I'm gonna show you also the engine start demonstration, the flight controls. So I will show you now the flight controls, how to control the aircraft flight controls using this side stick here in the simulation. So we're gonna have the side stick control here. I'm gonna show you how I use this side stick, the Lszh Extreme 3D, and these commands that yoke the control column and the control wheel and the control column of the aircraft. So you're gonna see how I control the horizontal tail, the elevator for climb and descent, the ailerons and the spoilers for bangles left and right, and also the rudder pedals for the vertical tail rudder and the nozzle steering of the aircraft. So I'm gonna show you now that. So you can see here we have the side stick. You can see I can move the yoke up and down, forward and aft, also make bang rolls left and right. So you can see the side stick deflection is proportional over here to the yoke deflection. Also we have the thrust levers, as you can see. So we have here also the other side. Both sides are interconnected. So when you want to climb or you want to descend or you make turns, left turns right like this. So you see the seismic deflection is proportional to the yoke deflection. Also the thrust levers here, you can move the thrust levers forward and use the side stick the same way. So you can climb, descend, bang roll right and bang roll left. Also you can see the rudder pedals. So I'm gonna show you now a little bit the outside view also of using the side stick and the flight control. So you will see now. So you can see here again how I can climb, descend, make turns left, make turns right. Left and right, and also the thrust levers again. So this is the climb and the descent, as you can see. I forgot to mention we have the horizontal tail trim stabilizer here, and also the auto throttle disconnect, and we have the horizontal tail trim here and here. So when you use the flight controls for flying the aircraft, I'm gonna show you a complete flight after explaining the systems and make an engine start demonstration. We will make in the end of the video complete flight from takeoff, climb, cruise, descent, approach and landing, so you will see all the phases of flight. So stay tuned. Now we have the overhead panel now systems, the electrical, the hydraulic, the primary flight control computers, the electrical that includes the left and the right engine drive and electric generators, the IDC, the hydraulic pumps, the fuel tanks, left and the right wing center tank, fuel booster pumps, fuel jettison, electronic engine control for the engines, auto start system, wing and engine anti-ice cabin pressurization, and the bleeder, the pressurizer from the left and right engine, also from the APU. We're gonna start the APU, turn off the engines and make an engine auto start. So you're gonna see this, and then we're gonna make a complete flight. So thank you very much for joining me and staying until the end of the video. I'm Thomas Hatsios, the British American pilot flying the Boeing 787-900 tonight. I'm gonna show you now the rest of the aircraft systems as much as we have time. So you can see here again the view. You can see if you zoom in the runway, we can zoom in a lot. So we'll have the airport here displayed, and the runways you see here where we are located, just in front here. We have the GPS position, the direction, magnetic heading. You can see the runway 16 and the runway 14. So you see the runway here, and here we have this. So you can see that here also we have the traffic display. Maybe we're gonna have an aircraft coming in. Legs. Let's see, home. So maybe here we have it, the display of the waypoints. So I'm gonna show you now The display here, you can see. So you can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the pitch ladder in degrees, the barometric altitude we are located, the target altitude, the radio altitude. You can see the map here again on smaller page. Some systems, the flaps, the engines, the left engine, right engine. I explain you N1, exhaust gas temperature, N2, fuel flow, oil pressure, oil temperature, oil quality, vibrations. So we have the N1, which is the low speed starter, it's at low pressure, compressor, and one of the turbofan, which is the engine, and the N2, which is the high speed starter, it's at the high pressure compression, and one of the turbofan, which is the engine. The fuel flow, you can see the fuel control switches here. We can turn on and off the engine using the fuel control, just like the 777. The fire extinguishers for the left and the right engine, the transporter here. We have the rudder trim here. We have the stabilizer trim cutout switch here. You can see we can turn on the stabilizer trim. We have the parking brakes up and down, smaller switch. So a few more minutes to go into the flight. So we have also electronic flight bar here. We will use it after we complete the flight. So you can see the landing gear here, extend and retract, just like in the 777, the auto brake, the alternate gear, lock override. So you can see a few more systems here, the overhead panel. You can see the electric left engine, right engine, the APU. We need to start the APU now, like this. So we will have the systems displayed here. The electric, the system status. You can see the APU now is running, is starting. So we start the APU. We have a few more minutes to go for the takeoff. We have also other things to see. The electric, you can see the left and the right engine, the ITG. The APU is gonna run in a couple of seconds. It's almost ready. The APU generator, you will see it functioning. The hydraulics, you can see the left and the right engine. Hydraulic pump 3000 psi, 5000 psi, left, right and center. The fuel system, the left and the right wing fuel tank, the total quantity of fuel, the minimum fuel temperature below which minus 37 degrees it will freeze. So you can see the center tank has some fuel. All engines, both engines are fed from a low and high pressure fuel valves, and the crossfeed valves right now is solved, but they can balance the fuel between the right and the left fuel tank, and also feed either engine with other pump. As you can see, we have also here. So we're gonna have the engine start demonstration in a couple of minutes. So you can see here the electric that I show you, the left and the right engine, IDZ, 180 to 200 volts, 400 Hz frequency, alternate current, 3-phase. Also the primary flight control computers here, the IRS localizer here, the flight control surfaces over here, um, the window sheet, the rammer turbine over here, the hydraulic. If we unlock this, we cannot also turn it back on, I believe. So this will give us the rammer turbine. When we are perhaps in the air. So we have still the fuel page. So you can see the fuel here, the left and the right wing fuel tank, the center tank, the crossfeed valve, the fuel jettison. We can dump some fuel in flight. You can balance the fuel using these switches. So we have also the electronic engine control for the engines. Over here, the auto start on. So I'm gonna show you also that how to use the auto start. So the hydraulics, you can turn off all the hydraulics. Maybe we're gonna have some hydraulics failure, you're gonna see. So we turn off all the hydraulics, turn them on again. So this is why we don't need the rammer turbine. It's not necessary for us right now because we have the hydraulics, so it's not deploying. So if we lose the hydraulics, it will deploy over here, provide some hydraulics, as you can see. The rammer turbine is unlocked. So we're gonna use also this just in case we need hydraulic power. So we turn on back the hydraulics. The fuel tanks, the wing and engine got the ice here, just like in the 777. So you can see here how the overhead panel is set. The fuel tanks, the pressurizer, the cabin pressurization system. Also we have the cabin pressurization also, in case we need to use the outflow valves. Open and close. So we're gonna make an engine start demonstration now, and we're going for flight. So we're gonna see the rest of the systems. The air system, the pressurizer from the left and the right engine. The doors are closed, the cabin can be pressurized. So the air system also has the APU. We need the APU to start the engines. The left and the right engine started. The landing gear, you can see the temperature of the brakes and the pressure of the tires. The flight controls, we can move the flight controls around. You will see the flight controls movement like this. Also the FEs, the maintenance and the circuit breakers that we have. So we have also the navigation display. So we're gonna have the CDU here. We're gonna turn off both engines. You can see the horizontal tail trim stabilizer cutout switch. We're gonna use the manual trim if we cut out that, if we have a hydraulic failure. So we turn off both engines, left and right off. And we're gonna make an engine auto start. So we're gonna make an engine auto start now. I'm gonna turn on both. I believe we can do that both. So you will see the reset here. You can see both are off now, both engines. Engine shut down. Right now fuel pump, outflow valve aft. So this is no engines now. You can see the right and the left. Over here the spinners are running somehow. So we're going now for the auto start. I'm gonna turn on both fuel control switches, the left and the right here. So this will give us the necessary fuel, and the spark you're gonna see auto start is on. What is reading? Both engines. So we have the auto start almost complete. So we have the running of the engines. So now we may proceed for the takeoff. We have also the speed brakes. This is speed brakes up, extend, retract. The flaps position, up and down. You see where the flaps are over here. We have also the thrust reverser. You pull up this, it extends also the speed brakes, and you can use the reverse thrust here. You can see reverse thrust. So I believe we are ready for the fly now to proceed to the takeoff. So we're gonna have like a few more minutes. So we have completed. So we have completed the engine start. Now we're gonna make a complete flight. We're gonna start the takeoff process. We're gonna taxi into the runway for takeoff, climb, cruise, descent, approach, and landing. So you're gonna see the whole flight now with the Boeing 787-900. We're gonna start now. We take the runway clearance. So we advance the thrust levers forward. So we advance the thrust levers. Thrust reverse. Disarm the thrust reverse. So we're ready to taxi. Disarm the parking brakes and go. We took the clearance from the air traffic control. So we advance the thrust levers forward a little bit. So this will give us an initial roll. So the runway is open for us for takeoff. We can proceed here for takeoff. A little bit of parking brakes. And we continue now. So we have legs again, the auto throttle here, left and right. The airspeed knob here, we're gonna set the airspeed. The L knob, we're gonna use the heading knob for the runway. And the altitude set. So you're gonna see how we're gonna climb from here. We have the runway. And we are just ready for departure. We only need to set the flaps up like 15 degrees and they are okay. We have the horizontal trim also set automatically. So this is where we are now. So we advance the thrust levers forward and go. Parking brakes off. So we have V1, we rotate, and V2 when we take off. And we have positive rate of climb, landing gear up. Just took off from the runway. So you can see we are here 2,500 feet above the ground level, 4,600 above the sea level. The airspeed, the stall speed here, the airspeed selected, the altitude selected, the rate of flight 4,700 feet per minute, the engine thrust rating here. and we need to start making the turn. Perhaps we need to increase the airspeed component. So we're gonna shortcut a little bit this way, fly straight to the waypoints. So here we are just climbing out from the Zurich, and you can see the Switzerland, this beautiful view. So this is a Boeing 787. Also we have the night sky here, this beautiful view of the star sign. Hope you like the Boeing 787. So you can see also the other view. Of the 787 and the top view. So we're going for the first waypoint here. So we have to use this as the first waypoint to confirm the selection we made. So we're gonna have so we go here. We need to make a turn over here. So you can see the first waypoint we have to follow here. We cross 30,000 feet. Need to make a small turn to the right now, as we are over flying here. You can see we are approaching the lake. Here's the Swiss lake, and we have the view from the Switzerland, also the Germany, the Bayern Munich in front of us, and the France. So we're gonna keep climbing. We have the cabin out, we have to set here, automatic. So we keep climbing. We're gonna have the chemtrails in a couple of we need the altitude first difference. Maybe we need to climb even higher than we are right now. So we almost reach the cruise altitude here. You can see also the engines are commanded right now, the thrust, and we have the LNAV to use. So we're cruising here 35,300 feet. So we have the flight director on also now. 35,000 as you can see, 300. Here and here. So we are approaching here. We're gonna have also the chemtrails and the contrails. We need to increase the altitude, maybe like a couple of thousand. So we're gonna climb to 39,000. We have to cruise through this waypoint. We can start an early turn to the airport also. So here we are, we make the turn and we climb. gonna climb a higher cruise level for a while, so you're gonna see the handrails coming, the frozen vapors. So we need to increase also the airspeed commanded now. And retract the flaps also. So we are very close to the stall speed, as you can see. It's flying manually. Still not having the handrails here, the contrails. So we are 27,000 feet. Perhaps we have we need the flight level change speed, but why it keeps decreasing. So we have reached the altitude where we have the frozen vapors now, as you can see from the aircraft. So this is the frozen vapors, the handrails and the contrails of the Boeing 787, and we cruise manually 28,000 feet above the ground. We're gonna fly to 29,000. So this is the spacecraft for tonight, flying almost 900 kilometers an hour or 300 meters per second, and we cross through the Switzerland. We have the Germany behind and the France is way in the beautiful star sign. You can see also further away if we look on the map. So here we are, 39,000 feet. We need to level off here, cruise level, and we're gonna start the descent now back to the airport. So we have the lake behind us, as you can see. we have to start also the descent. So this is the Boeing 787-900, the jet aircraft. So we need to start the descent in a couple of minutes. So we can also connect the autopilot if we wish. See how the autopilot command is. So this will increase the airspeed. And we have the autopilot cruise. We can set the airspeed a little bit higher. Also we can select a lower altitude for descent because we need to go back to the airport and the vertical speed. So this will give us this autopilot commands right now, as you can see. And now vertical speed, and we are descending, as you can see. So this will give us a higher airspeed. We need to use also the speed brakes, and the thrust will go moderate into a lower setting as we descend. You can see the rate of descent here. We have idle thrust also. So we are descending now. We're gonna have the airport this way. So we are approaching the runway here, the airport. So we cross 18,000 feet here. $15,000. We are in a good descent path over here as we keep descending. So we fly with almost descending. Disconnect the autopilot. Need to descend a little bit further, I believe. Landing gear also down. Select a lower airspeed right now. For approach and landing, first airspeed here. So we have it now, the airspeed commanded, 13,000 feet. And we need to level off. Also use some flaps. As we are descending, and we need to turn to the runway. We need to use rudder. So now we have manual. We fly manually, we keep descending. This is also the war localizer. I believe it's a good idea. So here we are, we have the runway on a decrease. We increase the rate of descent. So here we are right now for the approach and landing. So we're gonna have a nicer view like this, I believe, of the 787 for the touchdown. So we have the manual thrust. Also we need to descend a little bit further for the Lszh localizer. And decrease the airspeed a little bit further. So we align a little bit further. We use the flight controls and manual thrust if we need. We have it in the auto right now. So now we need to align here. So you can see the Lszh localizer here, the airspeed, the rate of descent, the altitude above the ground level, the altitude above the sea level. So we need to hold level here, level off, as we are descending. So we are now nicer approach here. Useful flaps also. So here we are. So starts down. Parking brakes and reverse as fast. Full reverse. So we have the full reverse as fast now. So we made a very nice landing here. You can see all the landing gear. It's pretty much safe. The nose wheel, the aircraft is standing nicely into the runway. All the wheels, the nose wheel, the landing gear behind it, both landing gear. So that was a very nice landing, as you can see, using the Boeing 787-900. You can see maybe we have some more lightings here. As you can see now, better. You can see the landing gear here. Behind the wheels are perfectly normal. There is no breakage of the tires here or the metal parts of any wheel or any tire. You can see also the nose wheel here. It's perfectly safe here, as you can see. The nose wheel. So you see the aircraft is standing up the way it should be into the runway. Over here the forward wheels and the back also wheels. Standing level, no breakages of any wheel here. You can see all the wheels, the tires, also this side. So this the reverse thrust. So that was Thomas Hatsios, the British American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport back to Zurich International Airport. Thank you very much for watching. I'll see you next time. Bye bye.